To continue with this problem, we calculated that the z-score was negative 0.5. We need to find the p-value for that corresponds to that z-score. So if we look at table B, we look for a z-score negative 0.5. I'm seeing 30.85. Now the table B tells us this area to the left. Since our HA is also to the left, the table B value is our p-value. So we can say that the p-value is, if we just convert that percentage to a decimal, 0.3085. So now to make a decision, and this is where a part that kind of gives people a hard time. Another way to think about your p-value is that it's the chance that you're wrong if you decide to reject HO. In other words, to say in this situation that the new test gets less than 10% false positive, false negatives, wrong results. So, and the other thing they're telling us that's nice about this problem is that uh, there's a 5% level of significance. So that tells us that that's like a rule of thumb that we can go by. If we can safely reject HO or say that this new test is more accurate, if our chance of being wrong is less than 5%. Of course, unfortunately, with a p-value of 30% or zero point 0.3, that's a whole lot more than 5%. So that's too big a risk to say, yeah, this new test works better. So because of that, because that p-value is so large, we cannot reject HO, which means the new test isn't working any better than the old test. Okay, and that's how you make these decisions. That's how you make that connection. Hope that helps.